All right, welcome back. That was annoying. But anyway, attendance is done. I hope. Mr. Brown, up to you. So, we have this parabola. It's not a V, it's not a U. This is a parabola. All right, I want to move on, and I want to talk more today about the common parabolas. So if I take, and you don't have to take notes yet, so I'm going to push that off to the side, but I want to look at a graph. I'm going to zoom out. Whoops. All right, so we have just a piece of regular graph paper. What I can do with that graph paper is I can throw different parabolas on here. Okay, so if I put this parabola on there, I know that that parabola, I could draw on that, and I can tell you that that parabola is the parent function, but it is shifted up. It's shifted up 1, 2, 3, 4, 5, 6, 7, 8 places. So this would look like, if I was to draw it somewhere on a piece of scrap paper, this would be the function of x equals x squared plus 8. All right? I could also put this over here. This one would be the function of x is equal to, it's not shifted up or down, it's shifted to the right 1, 2, 3, 4, 5, 6, 7 places. So therefore we have an x inside the parentheses, and for this one we have to shift it right. So to shift it right, remember it's the opposite, so this becomes a negative 7 or an x minus 7. Okay? So what I want to look at is I want to look at a bunch of different parabolas, see how I'm able to take this parabola and I can move it anywhere I want. Well, I can do that because I know something about parabolas. Let's say I take these 4 parabolas. All right, let me zoom in on those. What do we know about these 4 parabolas? All right, this one is shifted to the right, and it's shifted to the right 1, 2, 3, 4, 5, 6, 7, 8, 9. This one's shifted left about 12 spaces. This one's shifted down about 16. And this one's shifted up about 20. I obviously can't count, I'm just guessing. It's shifted up, this one's shifted down, right and left. And we've been doing this, all right? What do all of these parabolas have in common? Anybody? All right, I don't know why that's funny. Anywho, what is common about these 4 parabolas is that they're the exact same size. They are the exact same size. So what I can do to prove my point is I can flip this over, and if I was to come up with a, let's say y equals x squared plus 4, I can do that. Y equals x squared minus 2, I can fill that in. Y equals x plus 2 squared, and y equals, I'm putting in y, same as the function of x minus 2 squared. Okay, so if I plug in, if I got a negative 2, negative 1, 0, 1, 2. All right, negative 2 squared is 4 plus 4 is 8. Negative 1 squared is 1. 1 plus 4 is 5. 0 plus 4 is 4. 5, 8. All right, there's our curve. All right, that's our vertex. Let's move on. Okay, negative 2 squared is 4. 4 minus 2 is 2. Negative 1 squared is 1. 1 minus 2 is negative 1. 0 squared minus 2, negative 1 and 2. Actually, you know what's pretty interesting about that? Look at that. Those two are both the vertex, and they are the lowest number. Negative 2 and 4 are both the lowest number. All right, so this one's going to obviously look like that, right? This one's just shifted down, so this looks kind of like that. This one is shifted up, so it's going to look like that. So at 0, 4, At 0, 4 is where its vertex is. At 0, negative 2 is where its vertex is. Okay, all right, let's see. I think I'm seeing something here. All right, let's zoom in a little bit. Let's look at these. These are a little tougher. One thing I don't like about these, if I pick my normal, negative 2, negative 1, 0, 1, 2, now let me just plug in 0. 0 plus 2 is 2. 2 squared, which is 4. Negative 1 plus 2 is positive 1 squared, which is 1. Negative 2 plus 2 is 0 squared, which is 0. 1 plus 2 and that's 9, and then this is 16. All right, what I don't have, I need to find my negative 3 and negative 4, because this keeps going down. It doesn't ever come back up. See how this goes down and then up? This goes down, and there's no up, so I gotta find the other half of my parabola. So negative 3 plus 2 is negative 1 squared, which is 1. Ah, there we go. I bet you this one's 4. Negative 4 plus 2 is negative 2 squared, which is 4. All right, bet you the next one's 9 and then 16. So then what's my lowest one? There's my vertex right there. Okay. All right, let's look at this one. Negative 2, negative 1, 0, 1, 2. I always start there. It's a good place to start. Negative 2 minus 2 is 0 squared, which is 0. Negative 1 minus 2 is negative 3 squared, which is 9. 0 minus 2, oh man, 0 minus 2 is negative 2 squared, which is 4. Oh. Everybody notice that? I did that wrong. Negative 2 minus 2 is negative 4. This is 16. Yeah, Dylan, I know. I did it wrong. You got me. Good catch. Okay? All right. 1 minus 2 is negative 1 squared, which is 1. 2 minus 2 is 0. Still going down. It's actually the opposite of this one, right? So, 3 and 4. I bet you 3 is going to be a 1 and 4 is going to be a 4. 4 minus 2, 2. Perfect. There's my vertex. Okay. Why? We have to look at these things. I know I'm going fast. We're going to talk more about this, but my vertex is the lowest number. These are all positive. They're all valleys. They all go up like that. All right? The lowest point is the vertex. So the lowest point on all of these is the vertex. I'm starting to see some commonality. So for all 4 of these, they are the exact same shape. Did everyone notice that? That on this side, 8, 5, 4, 5, 8. All right, it's that curve, but if I go down by 3, then go down by 1, then go up by 1 and up by 3. Down by 3, down by 1. Up by 1, up by 3. Down by 3, down by 1. Up by 1, up by 3. So our parabolas all start at 0. They go up by 1 on both sides. And then from that one, they go up by 3. And then, believe it or not, they go up by 5. And then they go up by 7. All right? So that would actually look something like that. So our parabola has that perfect commonality. They are all the exact same shape. Now, yeah, I know, Jake, you're saying, okay, what happens when we have a parabola that is the function of x equals 2x squared? Yeah, it's narrower. It's not what I'm talking about. Pretend like that number doesn't exist today. For today, we're just looking at shifts up, down, left, and right. Or upside down, actually. They all have the same shape. And we can use that shape to help us find the vertex. Why is the vertex so important? That vertex is the lowest extreme point in all of these. Or if it was a negative parabola, it would be the highest extreme point. It would be the maximum. So for this one, the maximum or the vertex would be that point right there. okay? We also can tell our axis of symmetry. That's the point in which it is mirrored on flip-flop of both sides around the vertex. So that's actually really helpful for graphing these graphs. Okay? Really helpful. So let's do this. What I want us to do is I want us to analyze these 4 graphs. Okay? How I want to do that is I want us to come up with a plan or a system to graph maybe something that looks more like this. Because we know that the equation for this one is going to shift it right and it's going to shift it down. Okay? It's going to shift it to the right and it's going to shift it down. So we could come up with a system. How many to the right and how many down? And then we can write that equation from this. That can't be hard. It's just the backwards form of what we've been doing. All right, let's actually take a look at that a little bit. So, this graph right here, this graph is going to look like something. Hats, please. Did I get anybody? Brian looked. I know it. All right. Hopefully you guys are having as much fun as I am. I'm going fast. Mike, Mr. Brown can always pause it, rewind it, whatever you need. Okay. So, this one right here, I can write the graph of this one as the function of x is equal to, that's a regular x squared. It's not negative, it doesn't go upside down, it just shifts to the right. So what I have to do is I have to get rid of that 2. Damn it, I need white out. All right. There, white out, good to go. Function of x is equal, it shifts to the right, so we have to have something that looks like this. If it's to the right, we know that it's opposite what we think. In this case, this is positive x values. It's to the right, so it has to be a negative 1, 2, 3, 4, 5, 6, 7, 8, 9. That graph is this function. If I take that graph and move it up 4 places, same shift to the right, but now I can just add 4. Hopefully you guys can see this. Does that make sense? I've shifted it to the right. There's my x minus 9 squared. I then shifted it up and got the positive 4. All right, let's do another one. What if I do this? What if I do that? I'm going to zoom in a little bit for you so you can maybe, if anybody wants to count. Okay, well, I start with my function of x. All right, so I can start by where is this vertex? Yeah, let's make this easier. Let's do that so it's easier to count. All right, so my function of x. So it is shifted to the left. So it's going to look something like that, right? Shifted to the left 1, 2, 3, 4, 5 places. So if it's shifted to the left, it has to be positive. It's counterintuitive, so positive, what did I say that was? 1, 2, 3, 4, 5. And it's shifted down 2, minus 2. Shifted down 2 from that thing with the stuff, the x-axis, down 2 places, left 5 places. All right, pretty straightforward. This parabola didn't change at all. The shape is still the same. There's nothing. Oh, I bet you Charlotte saw this one. Yeah, that's not a U. This has to be a negative. Good thing I don't make mistakes. Right, Michaela? Yeah, okay. So, negative x plus 5 squared minus 2. All right, there's that function. Okay. This function has the same commonality because it doesn't have a number or numerical value in front of this. What we can do is we can basically come up with where that vertex is by looking at the values in here. The vertex on the y-axis is shifted down. This shifts it down, doesn't it? Shifts it down 2 places. So this is the vertex position on the y-axis. You might want to write that down. You can pause this if you want, Mike. I bet you Brittany wants to write it down. She's so studious. Dylan, I'm sure you'll want to write it down. Heather's very good at taking notes. All right. Now, it is also shifted to the left. 1, 2, 3, 4, 5 places to the left. Oh, look at that. This is the vertex's place or position on the x-axis. But it is opposite, negative for positive. Okay, whoops. Okay, so why did I just do that? Oh, that's better. So this is actually, what you're seeing here is a function. It's an equation, and it's in a very specific form. The reason we've been writing it this way is, well, number one, it's easy to plot. All right? Anybody giggle when I said plot? Okay, good. So it's easy to plot these values. It's also easy to find the vertex. Once you know the vertex, we know that if we have a vertex, I can take that vertex and I know exactly where the line of symmetry is. Right there, or axis of symmetry. This half is exactly the same as this half. This one has the line of symmetry. Perfectly right in the center. This one has it on the y-axis. But now it's a mirror image, so we know the furthest most point. If it doesn't narrow or widen, then we know up 1 over 1, and then up 3 over 1, and then up 5 over 1, and then up 7 over 1, up 9 over 1. What? This gets easier and easier. Math is amazing. All right? So, where was I? Oh, right, okay. So, what I want you to do is we're going to come back to this on Tuesday. We're going to put these notes, something like this, similarly in your notebook. What I want to do today is I want to go over what this means right here, all right, and come up with one. So in our notebooks, can we flip a page from the brain rip? All right, 1 page, Ryan. Don't go mixing up. Don't just pick a random page. All right, Ms. Zorzi, there's just a random page in there. Leave that one. Go right to the next one. Leave that one blank. Blank, blank. This one, let's write on this one. Okay? I'm going to pause this for a second and find out how long I've been going.